In this video tutorial, we're going to solve this hard algebra problem. We will simplify this expression and find simple equivalent expression that depends on values of parameters m and n. We will also investigate for what values of parameters this expression exists. First of all, to solve this problem, let's denote this part of our problem as A and denote this part of our problem as B. And let's first of all find B minus A. To do this, first of all, let's concentrate on A. This is A, can be, let's rewrite first of all A, 2 plus n divided by m plus m over n divided by 4 over mn minus 1 over n squared minus 4 divided by m squared. This can be written as mn times 2mn plus n squared plus m squared divided by 4mn minus m squared minus 4n squared. Now we see that after transformation of A, we have a denominator of our fraction A the same as denominator of B. And now we can perform subtraction and write what is B minus A. B minus A is equal to, let's rewrite B. It's 4m squared n squared divided by 4mn minus m squared minus 4n squared. And minus, in denominator we have 4mn minus m squared minus 4n squared. In numerator we have mn times 2mn plus n squared plus m squared. And this is equal to, we have common denominator, so it's quite easy to calculate. In numerator we will have 4m squared n squared minus mn times 2mn plus n squared plus m squared. This is equal to 2m squared n squared minus mn cubed minus m cubed n. And here we know that this denominator, actually we can write it as minus m squared minus 4mn plus 4n squared. And this is equal to minus m minus 2n squared. So now we can write here in denominator minus m minus 2n squared. Next, if we take out again mn, we will have in numerator of our fraction 2mn minus n squared minus m squared divided by minus m minus 2n squared. And here, of course, this part is equal to, it can be written as minus m squared minus 2mn plus n squared, which is minus m minus n squared. And all in all, it can be written as mn divided by m minus n squared, mn times m minus n squared divided by m minus 2n squared. It was b minus a, but here in our problem we have to calculate not only b minus a but square root of b minus a. That's why b minus a square root of b minus a will be equal to square root of mn times absolute value of m minus n divided by absolute value of m minus 2n. Now, at the moment, we know b minus a to the power 1 over 2, or square root of b minus a. We simplified just this part of our problem, or in other words, we simplified just this part of our problem. Next, we have to divide this simplified part by this expression. Let's do it. And write it as b minus a to the power 1 over 2, divide it by square root of mn over m minus 2n. And it will be mn times absolute value m minus n divided by absolute value of m minus 2n times m minus 2n over square root of mn. We have a cancellation, and here these two parts of our problem, we do not have a cancellation because sign of this expression is also important. That's why we write it as absolute value of m minus n times m minus 2n divided by absolute value of m minus 2n. This is final answer for our problem. Now let's rewrite in more simple form and get rid of our absolute value sign for different cases of parameters m and n. This is not a final answer of our problem because we can write this answer in more simple form. To do this, we have to make a little investigation of our problem. Here, first of all, we have to notice that in our problem, n must be not equal to 0 because of this element. M also must be not equal to 0. And also, m must be not equal to 2n because, for example, here in our problem, when we was solving our problem, we had this term in denominator. That's why when m is equal to 2n, we have a division by 0. That's why m must be not equal to 0. Next, we have to notice that in our problem, first case, when m is positive, because of this element, n also must be positive. Because when n is negative, we have negative number under the square root. Next, when m is negative, n also must be negative. Because of the same reason here, m and n can be negative, but multiplication of these two numbers can be positive inside square root. And of course here, depending on is m and n positive or negative, we always have the same. We always have the same because when m times n have the same sign, in this case, m times n is always positive, and so on. This number will be always positive, and also this number is always positive. This division, when n and m have the same sign, is also positive, and so on. That's why we have to use these conditions to write the final solution for our problem. First of all, let's assume case 1. Case 1, when m minus n is positive, or equivalently m is bigger than n. In this case, we have absolute value of m minus n is equal to m minus n. Or this term will be equal to m minus n by definition of absolute value. Inside case 1, we can divide this into two subcases. Case 1.1, when m minus 2n is positive, or m is bigger than 2n. In this case, m minus 2n, an absolute value of this number, is equal to m minus 2n. And the final answer of our problem, assume this is our problem, final answer will be, since this will be m minus 2n, it will be m minus n. This is final answer for this case. Second case, case 1.2, in this case, m minus 2n is negative, or m is less than 2n. In this case, absolute value of m minus 2n is equal to minus m minus 2n. And final answer, in this case, will be n minus m. Okay, it was case 1. What about the second? Case 1 was when m minus n is positive, and second case is when m minus n is negative. Case number 2, when m minus n is negative, or equivalently m is less than n. In this case, absolute value of m minus n is minus m minus n. In this case, we have two subcases also. Case 2.1, when m minus 2n is bigger than 0, or m is bigger than 2n. In this case, absolute value of m minus 2n is equal to m minus 2n. And final answer will be n minus m. And last case, case 2.2, in this case, m minus 2n is negative, or equivalently, m is less than 2n. In this case, absolute value of m minus 2n is equal to minus m minus 2n, and the final answer of our problem is equal to m minus n. So depending on different cases of parameter, answer of our problem will be m minus n or n minus n. And these four cases can be written in more simple form. Let's write final answer of our problem. The first case, when m and n are positive. As we said in previous discussions, the sign of parameter m and parameter n must be the same. Both parameters can be positive or negative. In second case, when m and parameter n are negative. In this case, this is assume this is parameter m, and we have 2 points in our line. This is n and this is 2n. We divide our line into 3 parts. Here, when m is bigger than 2n, we have m minus n. When m is between n and 2n, we have n minus m. And here we have m minus n. When m and n are negative, in this case we have n here, and number 2n will be here. In this case we have here m minus n, here we have n minus m, and here we have m minus n. So this is the final answer. Answer for this problem can be written in more compact form. We can write answer. Answer is when absolute value of m is in this range, bigger than n and less than 2n, answer will be n minus m. And otherwise, answer will be m minus n. And of course, as we noted earlier, we have to say that n must be not equal to 0, and m also must be not equal to 0, and m must be not equal to 2n. It was everything for this tutorial. Thank you very much. Have a great day.